Hi guys, today we're doing section 7.3. We're doing more specifics on matrices and solving them and row operations. We can go way more in depth, but we're only spending a little bit of time on this. And since we're at this point in the semester, a lot of this is going to be done on the calculator, but I am going to show you how to do some of this by hand. You can take entire courses on this in college, so boiling it down to one day. We're going to be missing something, but I'm going to try and give you the basics. So we're going to start with a systems of equations that has 3 equations. So you've got 3 equations and 3 variables, x, y, and z, all different equations. The whole reason we're doing this in the matrices unit is because we're going to be able to write matrices to represent this data. Again, matrix order and organize your data in order to make it easier to solve or to find things. So the first thing that we're going to have is a coefficient matrix. And our coefficient matrix is going to be exactly what it says. It's going to be all of the coefficients from my first 3 examples. So all of the coefficients for x will be my first column. All the coefficients for y will be the second, and all the coefficients for z will be the third column. And I'm just going to write that exactly like I see it. 1, 3, 2, -2, -5, -2, 1, 1, -1. I don't want any x, y's, and z's because this is just the coefficient matrix. So I'm only putting coefficients in here. We have a variable matrix, which is, again, exactly as it says. Our variable matrix is just going to have the variables. I'm going to have them in a vertical matrix. This is going to be a 1×3 matrix, x, y, and z. If we were to multiply these 2 matrices, we'd multiply like the first row by the column on this one. I've got a 3×3 matrix and a 3×1. I might have said that wrong before, I'm sorry. A 3×1 and a 3×3. And since they have that common middle number, then we're able to multiply these. And you can just think through this. The pink line would be exactly what this pink statement is right up here. 1x, -2y, 1z. Now, in order to get your answer involved, in order to get this equal sign involved, we are able to have what we call an augmented matrix. If I didn't want the answer in this matrix, I could just say equals, and then I'll just call it, I think it's the resultant matrix, which is just all the answers, which will give me 7, 14, 3. And we could make an equation with these 3 matrices, okay? Now, because I can't write a variable matrix in the calculator, we often don't do this because we're not doing a ton of by hand matrices. We're doing a lot of calculator ones. So I think I just said this, but we combine them with the augmented matrix. So the augmented matrix includes all of the numbers, all of the coefficients, and the answers in one big matrix. So I've got 1, 3, 2, -2, -5, -2, 1, 1, -1, 7, 14, 3. I remember when I was in college, when we did this by hand, we put like a line right here to remind us that we have like our square matrix of all the coefficients on this left side, and then our answers were on the right side. And I don't know if the book does that or not. So if you see a line there, great. If not, we're just assuming that the first 3 is your coefficients and the last row is what we call our answers, okay? So this is a form that we could write it in, an augmented matrix, okay? The next thing is that I could ask you to find something in row echelon form or reduced row echelon form. So row echelon form, spelled like this, ECHLON. Row echelon form is, again, it's a way to simplify your matrix. So row echelon form, if I was to take this matrix right here, it would be in row echelon form when I have it starting with 1, and then I've got some numbers here, here, and here. I don't know what those numbers are, so I'm not going to make them up. Then the next row would go 0, 1, and then would have some numbers. And then the last one would go 0, 0, 1, and then have a number. What this would tell us is that whatever this last term is, this is technically 1z right here, even though we aren't going to put z in the calculator, and it would tell us z equals this number. Then we could substitute that into whatever the second equation is and find y, and then substitute that in to the first equation to find x. Let's see if I have an example of that we can look at. I don't have an example off the top of my head. We're going to have to solve it in a second, and I'll show you that momentarily, okay? You may see row echelon form, and in your calculator, we'll do that in a second. It will be REF, row echelon form, okay? Versus I could ask you to do reduced row echelon form, and most of you will like this one better. Reduced row echelon form, or this time it's RREF. That means all I'm left with is ones and zeros in the 3x3, and then the last column are actual numbers. So all of the numbers in the 3x3 will be 1, 0, 0, and then those numbers, and then 0, 1, 0, and then that number, and then 0, 0, 1, and then those numbers. I did poor spacing. Let me move that over so it makes more sense. Okay. This tells you exactly what I have. It says z is equal to that number. It's going to say y is equal to this number, and it's going to say x is equal to that number. We can do an example where we're solving that, but if there are buttons in your calculator to press to go exactly from this augmented matrix to this form, or from your augmented matrix to that form. We're going to use those because I want to know what x, y, and z is, and we have these fancy calculators that lets us do that very, very easily. Okay, so we are going to do a quick example where it's in row echelon form, and we're going to solve from there, and then we're going to plug in, oh, actually, we're going to do it the other way. We're going to plug into the calculator first. So I hope I can switch screens pretty easily. So I'm going to give you an example, and the directions for this would say, solve finding row echelon form or reduced row echelon form. So we're going to do row echelon form first. So I would give you 3 equations, y minus x plus 2z equals -3, 2x plus y minus z equals 0, -x plus 2y minus 3z equals 7. Okay. So if I'm going to put this in my calculator, I need to first find its augmented form. So I've got 1, 2, -1, -1, 1, 2, 2, -1, -3, -3, 0, 7. I'm literally going to go to the calculator, type this into, what kind of matrix is it? A 3x4. And I'm going to go and press the button that says REF. Okay. I think I can switch my sharing. Okay. Screen share to my calculator. Share. Okay, here's my calculator. I'm going to go first and edit into my matrix. I've got, we'll just make A be a 3x4. And I'm going to type all of these letters in. 1, -1. Hopefully you're faster than I am at this. Okay, my matrix is done. So now I'm going to quit out of here, and I'm going to go to the matrix second, x to the negative first, and I'm going to go to the math column. That's where I told you DET was yesterday, the determinant. If you scroll down to A and B, REF and RREF. We literally just talked about those, and I said this one I want to be an REF. So I'm going to click on that. I want it to be done for matrix 1, so I'm going to, or matrix A, excuse me, so I'm going to go back, and under the names category, I'm going to press A, and then I'm going to press enter. And it gives me this matrix right here. Let's see if I can go back to my iPad. This is a fun game we're playing, isn't it? Okay, so when I put it in the calculator, I got out 1, 0.5, negative 0.5, and 0, 0, 1, negative 1.4, 2.8, and then 0, 0, 1, 3. I know that this third column is my z's. I can rewrite this as x plus 0.5 y minus 0.5 z equals 0, y minus 1.4 z equals 2.8, and then z equals 3. Z equals 3 is helpful, and I'm going to substitute that back in so that I'm able to solve for my other things. So I've got z right here. I'm going to plug that in, substitute it into the one above it. So I essentially have y minus 1.4 times 3 equals 2.8. Negative 1.4 times 3 is negative 4.2. So I'm going to add 4.2 to 2.8. And I get 7, so y equals 7, and then I'm going to plug both of those in above. So I've got x plus 0.5 times 7 minus 0.5 times 3 equals 0. 0.5 times 7 minus 0.5 times 3 is x plus 2 equals 0, so I minus 2 from both sides, x equals negative 2. So x equals negative 2, y equals 7, and z equals 3. I'm going to jump back to my calculator, and instead of pressing RREF, I'm going to press, or instead of pressing REF, I'm going to press RREF. And I'm going to go directly from this matrix to hopefully an answer. So it will be 1, 0, 0, something, 0, 1, 0, something, 0, 0, 1, something. Go back to my calculator. Okay, so now I'm going to press second, x to the negative first, go to my matrix menu. I'm going to press B this time. I'm going to go to matrix A because that's where all my information still is. And look at that. I have a matrix that says 1, 0, 0, negative 2, 0, 1, 0, 7, and then 0, 0, 1, 3. Negative 2, 7, and 3 are your answers for X, Y, and Z. And if you go back to your notes, that's exactly what we got. Okay. Stay tuned for video 2. That will come up in a second. And there's just a couple things I want to cover there, but you're good to start on things right now. Yeah, let me know if you need help.